So here's my setup. I'm using Ubuntu Linux, Emacs, and here's my terminal. Here's my directory. Let's run this application. Let's go through the index. So we have 3x9 canvases, and we're using 3x5 canvases, and we're using our dependencies P5 and Object Detect used in the application, and 5 sliders for thresholding. Let's open our sketch. So let's go through it quickly. We have our code commentary, width and height. We create the canvas and context. Set the width and height of every canvas. Some global variables. We have RGB to HSV function. We have RGB to XYZ, and then from XYZ to LAB for color conversion 1 and 2. We have our blur functions that divide the area into 3x3 pixels. 3x3 blocks. We have our pixels that divide the area into 5x5 blocks. We have within, we make sure that this given position is within the phase boundary of the detected face. We have some global variables of the detect classifier, face image, the setup, scale factor, and the detector for face detection. We draw. First we check the mode from the keystrokes 1, 2, 3, and 4. We have 4 different modes. The default is set to 1. We get the image for the 3x5 canvases, and here our main loop. So in our main loop, we first set the before the loop, we first set the webcam original image, increase the brightness by 20%. So in the original image is not brightness is not increased by 20%, but the other canvases are increased by 20%. So we can witness a difference between this one and this one. This one is darker, this one is brighter by 20%. We in our creative extension here on this right corner is a face differencing. We calculate the difference between current frame and previous frame, then calculate the grayscale and set the value to the frame differencing grayscale. So that is our creative extension canvas. Here is the grayscale, 3 channels, thresholding of the channels is striped. Let's set reduce the threshold value of the 3 channel. As you can see, it's changed. Let's change this. So that's our grayscale, the 3 channels, thresholding. It's simple. We make sure if the grayscale is greater than the threshold value by the slider, we set it to the channel value. Otherwise, we set it to 0. The same for the green and blue one. Okay, so the color conversion, we make the color conversion of the color space from the RGB to HSV for this one, and from RGB to LAB for this one, and the function is above. We went through it quickly. And thresholding color conversion. Here is the thresholding of this color conversion. So this is thresholding of HSV. Let's reduce it. And here is thresholding of LAB. Let's reduce it. So it's straightforward, very simple, similar to the above. Our face detection, we use face detect library or script from the Wiki 19 lecture or in the module. We get the faces, loop through the faces, and inside this area of the face, we get the index, calculate RGB for inside this detected face, calculate grayscale depending on our mode. We have 4 different modes. So if the face mode is 1, it's grayscale. So let's click 1. Let's open the console of this browser as well. So if we click 1, so we see a grayscale rectangle around my face here. So if we click 2, it should blur the detected face. So let's click 2. So it's blurred. It divides the rectangle into 3 by 3 blocks and takes the average. That is the blurring. And here our if we click 3, we make the inverted image. So let's click 3. It should invert the image to HSV color conversion only in the area of the detected face. I think I clicked 3. Let's click again. 3. I think the recorder is slowing my computer down. It's supposed to be detected. Let's click 3 again. And now we see the color conversion of inverted image of the face detection. And if we click anything else other than 1, 2, and 3, we should pixelate the image. We divide the block or the area inside the rectangle of the detected face into 5 by 5 blocks and take the average of this and loop 10 times over the pixelation function on the 3 channels. So let's click anything other than 1, 2, 3. Let's click 4. It should pixelate. And here we can see the fine grain pixelation. Thanks for watching.